Tonight we're diving into the peaceful evolution of the Hindu-Arabic number system and decimal notation development. Forget everything Hollywood told you. This is the real story, and trust me, you probably wouldn't last a day without these numbers. So before you get too comfortable, hit that like button if you enjoy this kind of deep dive, and let me know in the comments where you're watching from. Now, dim the lights, maybe grab that calculator you haven't touched since high school, and let's jump in. You wake up tomorrow morning. Your phone alarm doesn't go off because, surprise, there are no numbers on your screen, just Roman numerals. MCDXX3D messages waiting. Your bank balance shows MMMDCCXLD dollars and XCIX cents. Try calculating the tip on your coffee now. Go ahead, I'll wait. This nightmare scenario almost became our reality. If not for a peaceful revolution that took over 1,000 years to complete, you'd be doing long division with letters right now. And before you think I'm exaggerating, let me paint you a picture of what mathematics looked like before our heroes entered the scene. Picture ancient Rome, 50 BCE. You're a merchant trying to calculate how much grain you need to feed the legion. You pull out your counting board, basically an ancient spreadsheet made of wood and pebbles. Each column represents a different power of 10, except you can't write it down easily, because MMMDCCCLXXV8 times CDLVI equals actually nobody knows, because it would take you 3 hours and a team of mathematicians to figure it out. The Romans were brilliant engineers who built aqueducts that still function today, but their number system was like trying to perform surgery with a butter knife. Multiplication, forget about it. Division, may the gods have mercy on your soul, and the concept of zero didn't exist. Literally, they had no symbol, no placeholder, no concept for nothing, which is ironic because that's exactly what most Roman students probably learned about advanced mathematics. Nothing. Meanwhile, halfway across the world, something extraordinary was brewing. In the Indus Valley, mathematicians were developing ideas that would make your Roman merchant weep with joy. But here's the thing, revolutions in mathematics don't happen overnight. They happen over centuries, through trade routes, conquests, and surprisingly through peaceful scholarly exchanges. You're probably sitting there thinking this is going to be another boring history lesson about dead mathematicians. Wrong. This is a story about intellectual pirates, scholarly smugglers, and mathematical missionaries who changed the world not with swords but with symbols. And it all started with a simple realization that would seem obvious to any 5-year-old today, but was revolutionary at the time. What if instead of using different symbols for every number, we just used the same symbols in different positions? What if the position itself carried meaning? Sounds simple, right? Well, it took humanity approximately 5,000 years to figure this out. And when I say humanity, I mean specifically the ancient Indians, because while everyone else was struggling with their clunky number systems, these mathematical maestros were about to drop the numerical equivalent of the wheel. But before we get to that game-changing moment, we need to understand just how bad things really were. Comment below if you've ever tried to do math with Roman numerals. Actually don't. I know you haven't. Nobody has since the Renaissance, and there's a very good reason for that. The year is 3000 BCE, and you're in ancient Babylon. The air smells like clay dust and ambition. You're watching a scribe carefully press wedge-shaped marks into a soft clay tablet. This is cuneiform, and these Babylonians are actually pretty clever. They're using a base 60 system, which is why you have 60 seconds in a minute and 360 degrees in a circle today. Thank the Babylonians next time you're late for work. But here's where it gets weird. The Babylonians had a sort of placeholder, a space they'd leave empty to indicate nothingness in a number. But it wasn't a true zero. It was more like a shoulder shrug, a mathematical mumble that said, yeah, there's nothing here, but we're not going to make a big deal about it. They were so close to inventing zero, yet so far. It's like inventing the car, but forgetting to include the steering wheel. Now fast forward to ancient Egypt. You're standing in the shadow of a pyramid, watching scribes calculate using hieroglyphic numerals. They had symbols for 1, 10, 100, 1000, and so on. Want to write 276? Draw 200 symbols, 7 10 symbols, and 6 1 symbols. Efficient? About as efficient as writing this entire script in emojis. The Egyptians built monuments that have lasted millennia, calculated the flooding of the Nile with impressive accuracy, and yet their number system was essentially picture-based. Imagine trying to do your taxes with Instagram posts. That's basically what they were dealing with. And they made it work, which either makes them geniuses or masochists. Probably both. Meanwhile, the Greeks, those philosophical powerhouses, were developing geometric proofs that would make your head spin. Pythagoras, Euclid, Archimedes, these guys were mathematical rock stars. But their number system, they just used their alphabet, alpha for 1, beta for 2, and so on. It's like naming your children 1, 2, and 3. Functional but deeply unimaginative. The Greeks gave us democracy, philosophy, and the Olympic Games. But when it came to arithmetic, they basically said, letters will do. They were too busy contemplating the nature of infinity to bother with practical calculations. Which is peak Greek if you think about it. And then there were the Chinese, who had possibly the most practical approach. They used counting rods, physical sticks arranged in patterns to represent numbers. It was tactile, visual, and actually quite clever. They even had negative numbers way before anyone else thought to go below zero. But again, no true zero. It's like everyone was dancing around this concept, knowing something was missing, but not quite able to put their finger on nothing. You might be wondering why zero was such a big deal. Try this experiment. Write down the number 205 without using zero. Go ahead, I'll wait. You can't use a space, that's cheating. You can't use a dot, that's just zero with a diet. See the problem? Without zero, our entire number system collapses like a house of cards in a hurricane. The ancient world was essentially playing mathematical Jenga with a missing piece. They made it work through sheer determination and elaborate workarounds, but it was exhausting. Merchants spent hours on calculations that would take you seconds today. Astronomers made errors that threw off calendars for centuries. And don't even get me started on what tax collection looked like. So here we are, at the dawn of the Common Era. The Mediterranean world is using Roman numerals. The Middle East has various forms of counting. China has its rods, and everyone is struggling with the same fundamental problem. How do you represent nothing with something? How do you make absence presence? How do you give shape to the void? Enter India, specifically the Gupta Empire, around 400 CE. The air in Ujjain is thick with incense and intellectual energy. This is the golden age of Indian mathematics, and you're about to witness something that will literally change everything. Not figuratively, not hyperbolically, but literally every single calculation humans will make from this point forward. The Indian mathematicians didn't just stumble upon zero, they philosophically embraced it. See, in Hindu and Buddhist philosophy, the concept of nothingness, of void, of shunya, was already deeply embedded. The void wasn't scary or problematic. It was part of the cosmic order. What's existence without non-existence? What's something without nothing? These weren't just mathematical questions, they were spiritual ones. And this is where our story takes a beautiful turn. While Roman engineers were building impressive aqueducts with clunky numerals, Indian mathematicians were building elegant theories with elegant numbers. They created the decimal system, as we know it. 9 symbols plus 0. That's it. That's all you need to represent every number from 0 to infinity. Think about that for a second. Every number you've ever seen, every calculation you've ever done, every mathematical operation from your grocery bill to NASA's trajectory calculations for Mars rovers, it all comes down to 10 symbols that were perfected in ancient India. If that doesn't blow your mind, you're not paying attention, but here's the kicker. The Indians didn't hoard this knowledge. They didn't build walls around it or declare it sacred and secret. They shared it through trade routes, through scholarly exchanges, through the simple human desire to make life easier. This wasn't a violent revolution. Nobody died for the decimal system. It spread because it was simply, undeniably better. You're a merchant in 5th century India. You've just learned this new system. Suddenly calculations that took you hours now take minutes. Multiplication becomes almost trivial. Division still annoying, but manageable. You can write large numbers without running out of papyrus or clay. You can do mental math that would have required an abacus before. It's like upgrading from dial-up internet to fiber optic. The first recorded use of the decimal system appears in the Loka Vibhaga, a Jain cosmological text from 458 CE. It casually mentions the number 14,236,713, as if it's no big deal. Try writing that in Roman numerals. Actually don't. You'll be here all day and we have 9 more chapters to get through. But the real heroes of our story are mathematicians like Aryabhata, who in 499 CE wrote the Aryabhataya, a mathematical treatise that would make your high school math teacher weep with joy. He calculated pi to 4 decimal places, figured out that the Earth rotates on its axis, and basically laid the groundwork for trigonometry. All with this new decimal system. Then came Brahmagupta in the 7th century, who wrote the rules for 0. You can't divide by 0, he said. Adding 0 to a number doesn't change it. Multiplying by 0 gives you 0. These seem obvious now, but imagine being the first person to codify the rules of nothing. It's like writing the user manual for empty space. And here's where the story gets really interesting. This knowledge could have stayed in India. It could have remained a regional innovation, like chopsticks or cricket. But mathematics has a funny way of not respecting borders. Numbers don't need passports. Calculations don't care about your political affiliations. The decimal system was about to embark on one of the most peaceful conquests in human history. No armies would march. No cities would burn. But within a few centuries the entire world would surrender to the simple elegance of 10 symbols. Comment below if you think math is actually the world's most successful invasion, because what's about to happen next makes Alexander the Great look like a small-time local warlord. Baghdad, 786 CE. The air is thick with the smell of fresh ink and ambition. You're standing in the House of Wisdom, the Google headquarters of the medieval world. Except instead of free snacks and ping-pong tables, they have ancient manuscripts and the collected knowledge of 3 continents. The Abbasid Caliph Harun al-Rashid has just commissioned the most ambitious translation project in human history, and you're about to witness the moment when Indian numbers become Arabic numerals. Except here's the thing, they should really be called Indian numerals. The Arabs knew this. They literally called them Hindu numerals or Arqam al-Hindiya. But history has a funny way of crediting the messenger instead of the inventor. It's like calling email Wi-Fi messages just because that's how you received them. You're watching Muhammad ibn Musa al-Khwarizmi, whose name you can't pronounce but whose legacy you use every day. The word algorithm comes from his name. Algebras comes from his book title, Al-Jaber. This guy is basically inventing the language of modern mathematics while you're standing there, and he's doing it by translating and expanding on Indian mathematical concepts. Al-Khwarizmi is hunched over his desk, carefully transcribing Indian numerals. But he's not just copying, he's improving, explaining, contextualizing. He's writing on the calculation with Hindu numerals, a book that will change the world. He takes the Indian decimal system and makes it accessible to the Arab world, and from there to everyone else. The beauty of the House of Wisdom wasn't just in its collection of knowledge, but in its attitude toward that knowledge. These scholars didn't care where wisdom came from. Indian, Greek, Persian, Chinese. If it was useful, they wanted it. They were intellectual omnivores in a world of picky eaters, and they were about to serve the most satisfying mathematical meal the world had ever tasted. You walk through the halls and hear dozens of languages being spoken. Syriac Christians are translating Greek texts into Arabic. Persian Jews are explaining Babylonian astronomy. Indian scholars are teaching decimal notation. It's like the United Nations, except everyone actually gets along and accomplishes things. But let's not romanticize this too much. The scholars here weren't just nerds doing math for fun, though I'm sure some were. This was about power. The Abbasid Caliphate understood that knowledge was the ultimate weapon. Not knowledge of how to kill, but knowledge of how to count, calculate, navigate, and build. An empire that could calculate faster, could tax better, trade smarter, and expand further. And the decimal system was like discovering mathematical gunpowder. Suddenly calculations that would have taken Roman accountants days could be done in hours. Trade negotiations that required teams of mathematicians could be handled by a single educated merchant. The competitive advantage was so obvious that not adopting it would have been economic suicide. You're watching as a trader from Damascus learns the new system. His face goes through the 5 stages of mathematical grief. Denial, this can't be that simple. Anger, why didn't anyone tell me about this before? Bargaining, maybe I can use both systems. Depression, I've wasted so much time with Roman numerals. And finally, acceptance, accompanied by the kind of joy usually reserved for religious revelations. The Arab scholars didn't just translate, they innovated. They developed the concept of algebra as a separate mathematical discipline. They advanced trigonometry beyond what the Greeks had imagined. They created algorithms, those step-by-step procedures that run everything from your Instagram feed to your credit score today. But here's where our peaceful revolution hits its first major obstacle. You're now in Cordoba, Spain, around 950 CE. The Umayyad Caliphate controls the Iberian Peninsula, and with it, the gateway to European knowledge. Christian scholars from the north come here to study, and what they find blows their medieval minds. Imagine you're a monk from France. You've been doing calculations with Roman numerals your whole life. It's like you've been doing math with your hands tied behind your back while hopping on one foot. Then someone shows you Arabic numerals, and suddenly you have both hands free and can use both feet. The feeling isn't just relief, it's revelation. But the Catholic Church has a problem. These are infidel numbers. They come from the Muslim world, which borrowed them from the Hindu world, neither of which were particularly popular with the Pope. Adopting them felt like betrayal, like admitting that maybe, just maybe, non-Christians had figured out something Christians hadn't. This is where our story gets spicy. You have Christian scholars literally smuggling mathematical manuscripts across the Pyrenees, like they're trafficking in forbidden knowledge, which technically they were. Monks were copying Arabic mathematical texts in secret, hiding them in monastery libraries, teaching them to selected students who promised not to spread the heretical idea that mathematics could be easy. One of these mathematical smugglers was Gerbert of Aurillac, who would later become Pope Sylvester II. That's right, a pope was spreading Arabic numerals. He studied in Cordoba, learned the decimal system, and brought it back to Christian Europe. His contemporaries accused him of literally making a deal with the devil for his mathematical knowledge, because apparently being good at math was considered satanic, which explains a lot about my high school experience. Actually, Gerbert introduced the abacus with Arabic numerals to Europe. He taught them in cathedral schools. But here's the thing, he didn't include zero. Zero was too controversial, too philosophical, too nothing. Europeans could handle new numbers, but the concept of nothing as something was a bridge too far. You're in a cathedral school in Reims, watching Gerbert teach. The students are fascinated but confused. Why is the position of a number important? They ask. Why does moving a 1-1 space to the left make it 10 times larger? It seems like witchcraft. And in a world where actual witchcraft trials were a thing, that's not a comparison you wanted. The resistance was real. Merchants stuck to Roman numerals because that's what their customers understood. The church worried that easy calculations would lead to usury, which was considered a sin. Scholars argued that if God had wanted us to calculate easily, he would have given us 10 fingers. Wait, he did give us 10 fingers. Never mind, that's probably why the decimal system works. Meanwhile, in the Islamic world, mathematics was flourishing. Al-Khwarizmi was developing the binomial theorem. Al-Biruni was calculating the radius of the Earth. Al-Haytham was inventing the scientific method. The mathematical gap between the Islamic world and Christian Europe was growing wider than the Mediterranean. But ideas have a way of spreading, especially useful ones. Italian merchants trading with the Arab world couldn't afford to be mathematically inferior. If you're negotiating a trade deal, and the other guy can calculate profits and losses in his head, while you're still setting up your counting board, you're going to lose. Every single time. The pressure was building. The old system was creaking under the weight of increasingly complex commerce. Something had to give, and that something was about to come in the form of a young Italian, whose father really wanted him to be an accountant. You're in Pisa, 1170 CE. A baby is born, who will single-handedly drag Europe into mathematical modernity. His name is Leonardo, and his father calls him Fibonacci, son of Bonacci. Yes, that Fibonacci, the sequence guy. But before he became famous for rabbits multiplying in theoretical fields, he was about to become the most important mathematical ambassador in history. Young Leonardo's father is a customs official in Bugia, now in Algeria. Imagine being a teenager and your dad drags you to North Africa for his job. You're expecting a terrible time, but instead, you discover that the Arab merchants you're working with can do math like it's magic. They're calculating complex interest, currency exchanges, and profit margins while European merchants are still counting on their fingers. Fibonacci spends his youth traveling the Mediterranean, Egypt, Syria, Greece, Sicily. He's like a mathematical exchange student, except instead of learning languages, he's learning number systems. And everywhere he goes, he sees the same thing. The Hindu-Arabic numerals make everything easier. It's like everyone else is using smartphones while Europe is still banging rocks together. In 1202, Fibonacci publishes Liber Abaci, the Book of Calculation. This isn't just a math textbook, it's a revolution disguised as accounting advice. He doesn't just explain the decimal system, he shows European merchants exactly how it will make them rich. Forget philosophical arguments about the nature of zero. Fibonacci speaks the universal language, money. Here's a problem from his book. A merchant buys 7 pounds of pepper for 4 bezants. How much does 1 pound cost? With Roman numerals, you'd need a counting board, an abacus, or possibly a team of monks. With Arabic numerals, it's simple division. 4 divided by 7. Done. Next problem. Fibonacci was smart. He didn't try to convince scholars or theologians first. He went straight to the merchants. And merchants, God bless their greedy hearts, didn't care where numbers came from as long as they worked. If Satan himself had invented a better accounting system, medieval merchants would have adopted it and worried about their souls later. The book spreads through Italian counting houses like wildfire. You're a Venetian merchant in 1210. You've just learned the decimal system. Suddenly you can calculate compound interest without wanting to tear your hair out. You can convert between the dozens of currencies used across Europe without error. You can keep books that actually balance. It's like someone just invented Excel after you've been using an abacus made of pasta. But the church still resists. In 1299, Florence actually bans Arabic numerals in official documents. They claim it's because they're too easy to forge, which is partly true. It's easier to turn a 0 into a 6 than to forge Roman numerals, but really it's about control. The old system kept mathematics in the hands of the educated elite. The new system democratized calculation. Think about that. The city of Florence, which would become the banking capital of Europe, tried to ban the numbers that make banking possible. It's like Silicon Valley trying to ban computers. It was doomed to fail, and fail it did. By 1300, Italian banks are using Arabic numerals exclusively in their internal accounts, even if they have to convert them to Roman numerals for public documents. They're living a double mathematical life. Roman numerals for the masses, Arabic numerals for the classes. It's numerical segregation, and it's about to collapse. The Black Death arrives in 1347, killing a third of Europe's population. Society needs to rebuild, and it needs to rebuild efficiently. There's no time for mathematical nationalism. Arabic numerals aren't just convenient anymore, they're necessary for survival. You can't rebuild civilization while doing math the hard way. Comment below if you think the plague was actually what finally convinced Europe to adopt sensible mathematics. Because sometimes it takes a civilization-threatening crisis to make people abandon their stupid traditions. Welcome to the Renaissance, that glorious period when Europe finally admitted that maybe, just maybe, other cultures had figured out some things. It's 1450, and you're in Mainz, Germany, watching Johannes Gutenberg perfect his printing press. This magnificent bastard is about to do for the decimal system what social media would later do for cat videos, spread them everywhere, whether people wanted them or not. The first printed arithmetic book rolls off the press in 1478 in Treviso, Italy. It's called Arte dell'Abaco, and it's essentially Math for Dummies, Renaissance edition. The anonymous author, probably a merchant who got tired of explaining this stuff over and over, lays out the Hindu-Arabic numerals like he's revealing divine secrets. Which, to be fair, he kind of was. You flip through this book, the ink still smelling fresh, and realize that for the first time in European history, mathematical knowledge is being democratized. No longer do you need to study under a master for years to learn basic arithmetic. You can buy a book, sit in your shop, and teach yourself how to calculate. It's distance learning, 15th century style. But here's where it gets interesting. The printing press doesn't just spread the decimal system, it standardizes it. Before printing, every scribe wrote numbers slightly differently. A 4 might look like a triangle in Venice, and a crossed line in Paris. 0 could be a dot, a circle, or just an empty space depending on who was writing. Printing forces everyone to agree on what numbers look like. You're watching as typesetters carefully arrange metal number blocks, They're creating fonts, though they don't call them that yet. They're deciding that 6 and 9 should be the same symbol rotated, that 8 should be 2 circles stacked, that 1 should be a simple line. These decisions, made by German craftsmen who just wanted consistent printing, will determine how humanity writes numbers for the next 500 years. The merchant classes are eating this up. You're a cloth trader in Bruges, and you've just bought one of these new arithmetic books. Your competitors are still using Roman numerals and counting boards. You're calculating prices and profits in your head, while they're still setting up their equipment. It's like bringing a calculator to a finger-counting contest. But the universities are still resistant. You walk into the University of Paris in 1480, and they're still teaching mathematics using Boethius, a Roman philosopher from the 6th century. That's like teaching computer science today, using only vacuum tubes. The professors argue that Roman numerals build character, that they connect students to classical tradition. Sound familiar? It's the same argument people make against calculators in schools today. The battle lines are drawn. It's algorists versus abacists. The algorists use the Hindu-Arabic numerals and written calculation. The abacists stick to the counting board and Roman numerals. It's basically the Windows versus Mac debate of the Renaissance, except the stakes are the entire future of human calculation. In Germany, the Rechenmeisters, or calculation masters, are setting up schools to teach the new arithmetic. They're like coding boot camps, except instead of teaching JavaScript, they're teaching Indo-Arabic numerals. Adam Rees, the most famous Rechenmeister, publishes books that teach merchants practical mathematics. His books are so popular that Germans still say nach Adam Rees's, according to Adam Rees, when they mean something is mathematically certain. You attend one of these schools in Numeral. The Rechenmeister stands before a room of merchants, craftsmen, and their sons. No daughters, of course, because apparently ovaries interfere with arithmetic. He demonstrates multiplication using the new numerals. What would have taken an hour with Roman numerals takes minutes. The room gasps. One merchant actually crosses himself, as if he's witnessed a miracle. It's 1494, and you're in Venice watching Luca Pacioli put the finishing touches on his Summa de Arithmetica, Geometria, Proportione et Proportionate. This book is about to become the mathematical Bible of the Renaissance, and Pacioli is about to become the patron saint of accountants everywhere. Yes, accountants have a patron saint. It's Pacioli. Look it up. Pacioli isn't just writing about numbers. He's codifying double-entry bookkeeping using Arabic numerals. This is the system where every transaction is recorded twice, as both a debit and credit. It's the foundation of modern accounting, and it only works efficiently with the decimal system. Try doing double-entry bookkeeping with Roman numerals. Actually don't. You'll end up in an asylum. You're watching Pacioli teach at the court of Duke Ludovico Sforza in Milan. His student, sitting in the front row and sketching in the margins of his notebook, is some kid named Leonardo da Vinci. Yeah, that Leonardo, turns out the guy who painted the Mona Lisa, was also learning decimal notation and proportion from the Indiana Jones of Renaissance mathematics. Pacioli and Leonardo become bros, the original STEM and art collaboration. Leonardo illustrates Pacioli's next book on mathematical proportion. They travel together, teaching and learning. It's like a buddy road trip movie, except instead of hijinks and romance, they're spreading mathematical literacy across Italy. But here's the beautiful irony. The Catholic Church, which had resisted Arabic numerals for centuries, suddenly needs them desperately. The Vatican's finances are a mess. They're funding massive construction projects, managing properties across Europe, and running what's essentially a multinational corporation in cassocks. Roman numerals aren't cutting it anymore. You're in the Vatican treasury in 1500. The papal accountants have secretly been using Arabic numerals for years, but officially they're still publishing accounts in Roman numerals. It's mathematical hypocrisy of the highest order. They're like parents who tell their kids not to smoke while hiding cigarettes in their desk drawer. The Protestant Reformation kicks off in 1517, and suddenly the Catholic Church needs every advantage it can get. Protestant merchants are using Arabic numerals openly, calculating their tithes efficiently, managing their resources better. The Catholics can't afford to be mathematically inferior. It's adapt or lose Germany, and they've already lost Germany. By 1540, even the most conservative European institutions have surrendered to the decimal system. You walk into any counting house from London to Naples, and you'll see Arabic numerals on every ledger. The transformation is complete. It only took Europe 500 years to accept what India figured out in 400 CE. But hey, better late than never. The decimal system isn't just changing commerce, it's changing how Europeans think. The idea that position matters, that the same symbol can mean different things in different contexts, starts seeping into philosophy and art. Perspective in painting, which is essentially positional notation for visual space, develops alongside the spread of decimal mathematics. You're watching a young apprentice learn arithmetic in London. He writes 1 2 3 4 5 6 7 8 9 0, like he's writing the alphabet. To him these symbols are as natural as letters. He doesn't know they came from India via Arabia via Italy. He doesn't care, they're just numbers. The peaceful revolution is so complete that people have forgotten it was ever a revolution at all. The Jesuits, those intellectual shock troops of the Counter-Reformation, become the unexpected heroes of our story. They're establishing schools across Europe and the New World, and they're teaching Arabic numerals as standard. They're like mathematical missionaries, spreading the gospel of efficient calculation to anyone who'll listen. Let's zoom out for a moment and appreciate what just happened. Over the course of 1,000 years, a mathematical notation system traveled from India to Arabia to Europe, not through conquest or colonization, but through the simple recognition of its superiority. No armies marched for the decimal system. No one was burned at the stake for using zero, though they came close. It spread because it worked. But Europe isn't satisfied with just adopting the system, they want to improve it. It's 1585, and Simon Stevin, a Flemish mathematician, is about to invent something that will make the decimal system even more powerful: decimal fractions. Before Stevin, if you wanted to express half, you wrote 1/2. Stevin suggests writing it as 0.5. Mind blown. You're in Stevin's workshop in Leiden. He's explaining his system to skeptical colleagues. Instead of fractions with different denominators that need to be converted before you can add them, just use decimal points. Want to add 1/2 and 1/4? That's 0.5 plus 0.25 equals 0.75. No finding common denominators, no complex fraction rules. It's so simple, it's almost insulting. Stevin publishes Day Thien Day, the 10th, explaining decimal fractions. He argues this system should be used for everything: money, measurements, weights. He's basically advocating for the metric system 200 years before it's invented. The man is a prophet of decimalization, and like most prophets, he's largely ignored in his lifetime. But merchants love it. You're a Dutch trader calculating interest rates. With decimal fractions, compound interest becomes manageable. You can calculate percentages without wanting to throw yourself into a canal. The Dutch East India Company adopts decimal accounting, and suddenly they're the most efficient trading company in the world. Coincidence? Hardly. John Napier enters our story in 1614 with his invention of logarithms. This Scottish mathematician creates a system that turns multiplication into addition using decimal notation. It's like he invented a cheat code for mathematics. Engineers and astronomers lose their minds with excitement. Calculations that took days now take hours. You're watching Napier demonstrate his logarithms to astounded scholars. He multiplies huge numbers by adding their logarithms. He divides by subtracting. It's mathematical magic, and it only works because of the decimal system. Without positional notation, logarithms would be impossible. Napier is standing on the shoulders of Indian giants, even if he doesn't know their names. Then comes the real game changer. In 1617, Napier invents his bones, strips of wood with multiplication tables that work like a calculator. It's the first mechanical calculation device that uses decimal notation. You slide the bones together, read off the answer, and boom, instant multiplication. It's like going from walking to riding a bicycle. The decimal system is now unstoppable. It's in every counting house, every university, every workshop. Children are learning it in grammar schools. Street vendors are using it to make change. It's become so ubiquitous that people can't imagine mathematics without it. But here's the twist. As Europe is finally mastering the decimal system, they start colonizing the world. And what do they bring with them? The Hindu-Arabic numerals they fought against for centuries. They teach them to indigenous peoples, as if they're sharing European knowledge, conveniently forgetting where these numbers actually came from. You're in a colonial school in the Americas, watching European teachers instruct native children in arithmetic. They're teaching the decimal system as part of civilizing the locals. The irony is thick enough to cut with a knife. The very system Europe resisted as foreign and dangerous is now being exported as European enlightenment. Comment below if you think this is the ultimate historical irony, Europe spreading Arabic numerals that were actually Indian as if they were European innovations. Because colonialism wasn't just about taking lands and resources, it was about rewriting history to make the colonizers look like the inventors of everything useful. The year is 1700, and you're standing in the Royal Society of London, where some of the greatest minds of the age are arguing about the smallest things, infinitesimals. Newton and Leibniz have just invented calculus independently, and they're using decimal notation to explore the infinite and the infinitesimal. Without the Hindu-Arabic numeral system, calculus would be about as feasible as performing surgery with a spoon. Think about trying to write Newton's laws of motion using Roman numerals. F equals m times a becomes impossible. You can't even properly express the concept of acceleration without decimal notation. The velocity changes by tiny decimal amounts over tiny decimal time intervals. Try expressing 9.8 meters per second squared in Roman numerals. I'll wait. Actually, I won't, because we'd be here until the heat death of the universe. You're watching as mathematicians scribble equations that describe planetary orbits, the path of projectiles, the flow of fluids. Every equation is built on the foundation of 10 simple symbols. The decimal system has become so fundamental that it's invisible. It's like asking a fish to notice water. But let's shift our attention to money, because that's where the decimal system is about to face its biggest challenge yet. You're in London's Exchange Alley, where merchants are dealing with a nightmare. British currency isn't decimal. It's 12 pence to a shilling, 20 shillings to a pound. It's like someone deliberately designed a system to make calculation as difficult as possible. A merchant is trying to calculate the price of goods. He needs to add £3, 17 shillings and 9 pence to £4, 15 shillings and 7 pence. With decimal currency, this would be simple addition. With British currency, It's a mathematical obstacle course. You need to carry over at 12 and at 20. It's positional notation's evil twin. Meanwhile, in Russia, Peter the Great is modernizing his empire, and he starts with the currency. In 1704, he introduces the decimal ruble, 100 kopecks to a ruble. It's the world's first decimal currency, and it makes Russian merchants the envy of Europe. They can calculate prices and exchange rates, while British merchants are still converting shillings. You're in a St. Petersburg counting house. A Russian merchant completes a complex transaction in minutes that would take his London counterpart an hour. He's not smarter, he just has better tools. It's like comparing someone with a calculator to someone with an abacus, except the abacus is drunk and has irregular spacing. The Americans, those rebellious colonists, are about to make a decision that will seem obvious in hindsight, but revolutionary at the time. It's 1785, and the Continental Congress is designing currency for the new nation. Thomas Jefferson, that Renaissance man who apparently had opinions about everything, proposes a decimal currency. Jefferson's argument is beautiful in its simplicity. The decimal system is democratic. Any citizen who can count to 10 can understand it. No special education needed. No conversion tables to memorize. It's mathematics for the masses. Arithmetic for the average American. It's literally mathematical independence from British complexity. You're in Congress as they debate. Some argue for keeping the British system out of tradition. Others want to adopt the Spanish pieces of 8. Jefferson stands up and essentially says, "Gentlemen, we fought a revolution to free ourselves from British tyranny. Why would we keep their tyrannical mathematics?" In 1792, the U.S. Mint Act establishes the decimal dollar, 100 cents to a dollar. It's so simple it seems inevitable, but it was actually radical. The United States becomes the second country with decimal currency, and suddenly American merchants have a competitive advantage in international trade. But the real revolution is happening in France, where they're not content with just decimalizing currency. No, the French want to decimalize everything. It's 1791, and you're in the National Assembly watching as they unveil the metric system. This isn't just about measurement, it's about applying the Hindu-Arabic decimal logic to the entire physical world. The meter is defined as 1/10,000,000th of the distance from the equator to the North Pole. A kilogram is the mass of a liter of water. Everything is base 10, 10 millimeters to a centimeter, 100 centimeters to a meter, 1,000 meters to a kilometer. It's the decimal system applied to reality itself. You're watching French scientists literally measuring the Earth to define the meter. They're surveying from Dunkirk to Barcelona, triangulating distances, calculating arc lengths. It's the largest scientific project of its time, and it's all to create measurements that work with the decimal system. These madmen are reshaping physical reality to match mathematical convenience. But the French don't stop there. They try to decimalize time. 10 hours in a day, 100 minutes in an hour, 100 seconds in a minute. They create decimal calendars with 10-day weeks. It's decimal fascism, and it's magnificent in its ambition and hilarious in its failure. You're in revolutionary Paris, trying to buy bread with decimal time. The baker looks at you like you're insane. "What time is it?" you ask. 5 hours and 33 minutes, he replies, which in old time would be, "Nobody knows because the conversion is impossible, without a calculator that won't be invented for another 150 years. The decimal calendar lasts about as long as you'd expect, 12 years before Napoleon kills it. Turns out you can't just decimalize astronomy. The Earth stubbornly continues to orbit the Sun in 365.25 days, not some convenient power of 10. The Moon refuses to orbit in decimal periods. Reality, it seems, doesn't care about mathematical elegance, but the metric system survives and thrives. By 1875, 17 countries signed the Meter Convention. You're in the signing ceremony, watching as nations agree to use the same decimal measurements. It's perhaps the most successful international cooperation in human history. Countries that can't agree on anything else agree that 100 centimeters equals 1 meter, except for 3 countries that hold out like mathematical rebels. The United States, Liberia, and Myanmar cling to their imperial measurements, like life rafts in a decimal ocean. Americans measure distance in feet and miles, volume in gallons and fluid ounces, temperature in Fahrenheit. It's mathematical nationalism, and it's costing them billions. You're in 1999, watching as NASA loses the Mars Climate Orbiter because someone forgot to convert between metric and imperial units. A $327 million spacecraft crashes into Mars because America won't adopt the system the rest of the world uses. The Hindu-Arabic decimal system has conquered everything except American stubbornness. Meanwhile, computers are being invented, and guess what system they use? Binary, which is just positional notation with 2 symbols instead of 10. The principles invented in ancient India work just as well with 0s and 1s as they do with 0 through 9. Every calculation your computer makes is using the positional logic first developed for the decimal system. You're watching Alan Turing design his theoretical machine. He realizes that any number can be represented with just 2 symbols if you use positional notation. The decimal system's greatest gift wasn't the 10 symbols, it was the idea that position matters. That same symbol can mean different things depending on where it is. That's the foundation of all digital technology. Let's talk about how the decimal system literally went to space. It's 1961, and you're in mission control as Yuri Gagarin orbits Earth. Every calculation, from trajectory to fuel consumption, is done in decimal notation. The computers use binary internally, but display everything in decimal, because that's what human brains understand. NASA engineers are using slide rules, those analog calculators that only work because of logarithms, which only work because of the decimal system. You're watching them calculate orbital mechanics, with tools that would be impossible without Hindu-Arabic numerals. Spaceflight is essentially applied decimal notation with rockets attached. But here's something mind-blowing. Other intelligent species, if they exist, probably don't use base 10. They might have 8 fingers, or 12, or tentacles that don't lend themselves to counting at all. Yet any sufficiently advanced civilization must discover positional notation. It's not about the base. It's about the concept that position carries meaning. You're in a SETI meeting in 1974 as scientists design the Arecibo message, humanity's first deliberate broadcast to aliens. They need to communicate using universal mathematics. They send binary code that represents decimal numbers, that represent physical constants. It's like mathematical telephone, translating between number systems to find universal truth. The decimal system has become so fundamental that we've built our entire technological civilization on it. Every barcode scanned, every credit card swiped, every GPS coordinate calculated, it all comes back to those 10 symbols refined in ancient India. Your phone number, your social security number, your IP address, they're all decimal notation in disguise. You're in a modern classroom, watching kids learn math. They write numbers without thinking about it, arranging digits in columns, carrying the 1 borrowing from the 10's place. These operations that seem natural took humanity thousands of years to develop. Each child recreates the mathematical revolution in their notebook. But here's the thing that should keep you up at night. We're so dependent on the decimal system that we literally can't imagine mathematics without it. Try to conceive of advanced mathematics using only Roman numerals. You can't. Our entire understanding of quantity, measurement, and calculation is built on this foundation. In 2008, the financial crisis happens partly because decimal models of risk failed to account for real-world complexity. Traders trusted decimal calculations that said mortgage-backed securities were safe. The decimal system is so good at making complex things seem simple that we forget it's just a model, not reality itself. You're watching as cryptocurrency is invented, and guess what? It's all decimal notation converted to binary and back again. Bitcoin is mined using calculations that would be impossible without positional notation. The blockchain is essentially a decimal ledger distributed across thousands of computers. Even our attempt to revolutionize money relies on medieval Indian mathematics. The modern stock market runs on decimal pricing. In 2001, the US stock exchanges switched from fractions to decimals. Instead of prices moving in eighths or sixteenths, they move in cents. It seems like a small change, but it makes markets more efficient, spreads tighter, calculations faster. The decimal system conquers yet another domain. And now we're teaching machines to think, and what do we teach them first? Numbers, decimal notation. The same system that traveled from India to Arabia to Europe to space is now being encoded in neural networks. AI learns to count the same way humans did, starting with the symbols that Indian mathematicians perfected 1,600 years ago. Comment below what you think aliens would think of our number system. Would they be impressed that we figured out positional notation? Or would they laugh that it took us so long, and we still can't agree on metric versus imperial? Because the story of the decimal system is really the story of human stubbornness, slowly giving way to superior ideas. Let's talk about zero for a minute. Because this nothing is really something. You're in ancient India, 5th century CE, watching Aryabhata use a dot to represent nothing. Not just empty space, not just absence, but a thing that represents no things. It's like inventing a word for silence or a color for transparency. The human brain wasn't designed to think this way. Zero is the most powerful invention you've never thought about. Without it, the decimal system collapses. It's the placeholder that makes positional notation possible. In 205, that zero tells you there are no tens. Without it, you can't distinguish between 25,205 and 2005. It's the silent letter of mathematics, invisible but essential. But zero is more than just a placeholder. It's a number in its own right. You can add it, multiply by it, but God help you if you try to divide by it. That way lies madness and undefined results. Computer programs crash trying to divide by zero. It's the mathematical equivalent of asking what happened before the Big Bang. You're watching Brahmagupta in 7th century India write the rules for zero. He's the first to treat it as a number rather than just a notation. 0 plus a positive number equals that positive number. 0 times any number equals 0. These rules seem obvious now, but imagine being the first person to codify the arithmetic of nothing. The psychological resistance to zero was real. Many cultures couldn't accept that nothing could be something. The Greeks, those masters of logic, rejected it philosophically. How can non-being be? It's the mathematical version of an existential crisis. Parmenides would have had an aneurysm. In medieval Europe, zero was associated with the devil. The void, the absence of God's creation. Using zero was almost heretical. You're in a monastery in 1200 CE, and a monk is secretly using zero in his calculations, hiding it like pornography. If nothing comes from nothing, as King Lear says, then what sorcery is this zero that makes mathematics possible? But merchants don't care about philosophy. They care about balanced books, and zero makes accounting possible. A zero balance means your even negative numbers, which require zero as a reference point, let you represent debt. The entire concept of credit and debt accounting depends on zero. No zero, no modern banking. You're watching the first negative number transaction in an Italian bank. The merchant owes 50 florins, represented as -50. This blows everyone's minds. You can have less than nothing. You can owe existence. It's like mathematical science fiction, except it's happening in real life and transforming commerce. The Mayans independently invented zero, represented by a shell glyph. They used it in their calendar calculations, achieving astronomical precision that wouldn't be matched in Europe for centuries. Two civilizations, separated by oceans, both realized that nothing was necessary for mathematical progress. But here's the kicker. Zero makes infinity possible. Once you have nothing, you can conceive of everything. The number line extends infinitely in both directions from zero. It's the origin point of all quantity, the Big Bang of numbers. Without zero, you can't have negative numbers, and without negative numbers, you can't map the full range of mathematical possibility. You're in Newton's study. As he develops calculus, he's dividing by smaller and smaller numbers, approaching zero but never quite reaching it. This is the concept of limits, and it only works because zero exists as a destination you can approach but never quite reach. It's like zero's paradox solved through notation. The concept of zero transforms philosophy as much as mathematics. You're in Enlightenment Europe, and philosophers are grappling with the idea of nothingness. If zero can be something in mathematics, can nothing be something in reality? The vacuum previously thought impossible suddenly seems mathematically necessary. Descartes invents the coordinate system. With zero at the center, every point in space is now defined by its relationship to zero. You're watching him draw the first Cartesian plane, with 0, 0 at the origin. This isn't just mathematics. It's a new way of understanding space itself. Zero becomes the reference point for existence, but zero causes problems too. You can't take the logarithm of zero. Division by zero is undefined. Computer programs that don't check for zero division crash spectacularly. Y2K was essentially a zero problem, years represented by two digits rolling over from 99 to 0. The nothing that enables everything also breaks everything. If you're not careful, you're in 1975 watching the first electronic calculators being programmed. The engineers have to specifically code what happens when someone divides by 0. Should it display an error? Infinity? Just freeze? This nothing requires special handling in every system humans create. Zero enables the binary system that runs all digital technology. 1 and 0, on and off, true and false. Every tweet, every email, every digital photo is ultimately patterns of something and nothing. The ancient Indian concept of shunya, the void, has become the foundation of the information age. In quantum mechanics, zero-point energy suggests that even perfect vacuum contains energy. Nothing is never truly nothing. The philosophical implications that troubled medieval monks turn out to be physically true. Zero exists, but absolute zero doesn't. The universe won't let you reach perfect nothing. You're watching economists model the 2008 financial crisis. They're dealing with derivatives approaching zero value, assets worth nothing, negative equity. The mathematics of nothing becomes the mathematics of economic collapse. Zero isn't just a number, it's an economic state that can destroy nations. But zero also enables creation in computer graphics. Every pixel starts at zero, black, empty, nothing. Artists build images by adding values to zero. Every digital creation begins with nothing. It's genesis in binary, creation from void, except the void is mathematically defined. The temperature scale has zero, but which zero? Celsius puts it at water's freezing point. Fahrenheit puts it at the coldest temperature he could create with ice and salt. Kelvin puts it at absolute zero, the theoretical point where molecular motion stops. 3 different nothings, all equally valid. You're in a computer science class learning about null pointers, references to nothing that crash programs. It's zero's evil twin in programming, the nothing that points to nothing and breaks everything. Billions of dollars in software bugs come from mishandling nothing. Zero makes credit cards possible. Those 16 digits include zeros that serve as placeholders and checksums. Remove the zeros and the whole system collapses. Your ability to buy things with plastic depends on proper nothing notation. In statistics, the null hypothesis assumes nothing is happening, no effect exists. Scientists have to prove something exists by disproving nothing. It's philosophy through mathematics, using zero as the baseline for truth. Let's get weird with zero. You're in an advanced mathematics seminar discussing the Riemann hypothesis, one of the greatest unsolved problems in mathematics. It's about when certain functions equal zero, $1 million prize awaits whoever solves it. Literally $1 million for understanding nothing. The concept of zero leads to some truly mind-bending mathematics. Consider 0 factorial. The factorial of a number is that number times every positive integer below it. So 5 factorial is 5 katir 4 katir 4 equals sign 120. What's 0 factorial? Logic says it should be 0, but mathematics says it's 1. 0 factorial equals 1. Nothing operated on by nothing becomes something. You're watching a mathematician explain why 0.999 repeating equals 1. Not approximately equals, but exactly equals. The infinite series of nines after the decimal point reaches unity. It's zero's complement, the nothing that adds up to something. Students' heads explode trying to understand how something can equal something else plus nothing. In set theory, the empty set, a set containing nothing, is the foundation of all mathematics. Every number can be built from sets containing nothing. 0 is the empty set. 1 is the set containing the empty set. 2 is the set containing the empty set, and the set containing the empty set. All of mathematics built from nested nothings. You're in a computer lab watching machine learning algorithms initialize. Every neural network starts with weights set to small random values near 0, too far from 0, and the network explodes, too close to 0, and it never learns. The entire field of artificial intelligence depends on starting near nothing, but not at nothing. Black holes are where physics meets 0. The singularity at the center has 0 volume but infinite density. It's where our mathematics breaks down, where dividing by 0 happens in reality. The universe itself can't handle 0 properly. You're watching cryptocurrency miners solve equations looking for hashes starting with zeros. The more zeros required, the harder the problem. Digital gold is mined by finding nothing at the beginning of numbers. The entire Bitcoin network runs on competitive nothing finding. 0 enables information theory. Claude Shannon defined information as the reduction of uncertainty. 0 information means complete uncertainty. Maximum entropy. The heat death of the universe is when information reaches 0, when nothing more can happen. 0 isn't just mathematical death, it's thermodynamic death. In game theory, zero-sum games are where one person's gain equals another's loss. The total always sums to 0. Every poker game, every options trade, every war is allegedly zero-sum. Except they're not, because value can be created or destroyed. True zero-sum is as rare as true zero. You're in a quantum computing lab. Qubits exist in superposition between 0 and 1 until observed. Schrödinger's cat is both 0 and 1, dead and alive, nothing and something. Quantum computers exploit the uncertainty of 0 to solve problems. Classical computers can't touch. The Y2K bug wasn't really about the year 2000. It was about 0. 2-digit years rolling from 99 to 00. Computers potentially thinking 2000 was 1900. Billions spent fixing a zero problem, the nothing that almost broke everything. Comment below if zero is the most important invention in human history, because without nothing we'd have nothing. No computers, no calculus, no coordinate systems, no modern mathematics. The Indians didn't just give us a placeholder, they gave us the placeholder for existence itself, and we still haven't figured out all the implications of nothing being something. Now let's explore how different cultures almost gave us entirely different number systems, and what the world would look like if they had won. You're in ancient Babylon 2000 BCE, and these clever bastards are using base 60. That's right, 60 different symbols before they repeat. It's why you have 60 minutes in an hour and 360 degrees in a circle. The Babylonians lost the notation war, but won the time and angle battle. Imagine if base 60 had become standard. You'd need to memorize 60 unique symbols just to count. First grade would last until you were 12. But calculations with fractions would be easier since 60 divides evenly by 2, 3, 4, 5, 6, 10, 12, 15, 20 and 30. No more awkward decimals like 0.333 repeating for 1/3. It would just be 20 in base 60. You're watching a Babylonian astronomer calculate planetary positions. With base 60, he can express complex fractions simply. 1/3 of a degree, that's 20 minutes of arc. Try expressing that cleanly in decimal. You get 0.333 degrees, an infinite string of digits for something that should be simple. The Mayans went with base 20, probably because they counted on fingers and toes. You're in a Mayan temple watching priests calculate when the world will end. Spoiler alert, they were wrong about 2012. But their calendar was incredibly precise because base 20 works well with their 18-month years, plus a 5-day unlucky period. If we use base 20 today, computer memory would be organized differently. Instead of kilobytes being 1024 bytes 2 circumflex 10, they'd probably be 400 bytes 20 squared. Your hard drive would measure storage in powers of 20. The entire digital architecture would be alien to us. You're in ancient China watching someone use a counting board with base 10 for most things, but base 16 for weights. That's right, they were mixing bases like a mathematical cocktail. 16 tails to a catty. It's like having metric for distance but imperial for weight. Actually, that's exactly what Britain does today. The Romans sort of used base 5 within their system. But the C, it's counting to 5 then starting over with a new symbol. If they'd fully committed to base 5, we'd have a completely different mathematical world. Computers might use base 5 instead of binary. Every calculation would be fundamentally different. Binary itself is the ultimate minimalist number system. You're watching Leibniz in 1679. Realize that everything can be expressed with just 1 and 0. He saw it as proof of God, creation from nothing and unity. He had no idea he was describing the future of all human technology. If we'd adopted binary for everyday use, phone numbers would be hilariously long. Your 10-digit phone number would be a 33-digit binary string. Prices would look like barcodes. Math class would be easier in some ways. Multiplication tables would only have 4 entries, but harder in others. Imagine memorizing your binary social security number. You're in a computer science class where the professor is explaining hexadecimal, base 16, using 0, and AF. Programmers use it because it converts cleanly to binary. 4 binary digits equal 1 hexadecimal digit. If ancient civilizations had 16 fingers, we might all be using hexadecimal, and computer science would be kindergarten material. But here's where it gets really wild. Some cultures didn't use positional notation at all. They used additive systems, where you just keep adding symbols. You're watching an ancient Egyptian scribe write 999. He draws 900 symbols, 9 10 symbols, and 9 1 symbols. 27 symbols for a 3-digit number. His hand is cramping before he finishes. If additive systems had won, mathematics would have developed completely differently. No easy multiplication algorithms. No sliding decimal points. Scientific notation would be impossible. You couldn't write Avogadro's number, 6.022 Colte 10 circumflex 23, without filling entire books with symbols. The Greeks had a multiplicative system for large numbers. They'd write myriad for 100 million. It's poetic but useless for calculation. You're watching Archimedes try to express the number of sand grains needed to fill the universe. He invents new words for huge numbers because his notation system can't handle them efficiently. Some Native American tribes used base 8 octal because they counted the spaces between fingers, not the fingers themselves. If octal had spread globally, the digital age might have arrived sooner. 8 is 2 circumflex 3, so it converts beautifully to binary. Every octal digit becomes exactly 3 binary digits. It's more computer-friendly than decimal. You're in a parallel universe where humanity adopted base 12. Dozens are everywhere. Your ruler has 12 inches naturally. Time divisions make more sense. 1/3 is just 4 in base 12. 1/4 is 3. 1/6 is 2. Fractions that torture decimal users are trivial in dozenal, as base 12 enthusiasts call it. The French revolutionary calendar didn't just try to decimalize time, they tried to create new months with poetic names. Thermidor, the month of heat. Brumaire, the month of mist. If this had succeeded, you'd be writing dates like 15 Thermidor, year 232. Your birthday would sound like a wine vintage. Ternary base 3 is theoretically the most efficient integer base for computation. If we used it, computers might be built with 3 states instead of 2. Instead of on-off, you'd have -0/positive. Some Soviet computers actually used ternary. In an alternate timeline, Silicon Valley runs on balanced ternary. You're watching Soviet computer scientists in the 1950s build Seton, a ternary computer. It's more efficient than binary, in many ways. But binary wins because it's simpler to implement electronically. The entire digital revolution hinges on the fact that it's easier to detect 2 states than 3. Imagine if we used prime-based notation, where numbers are expressed as products of primes. 12 would be written as 2 quad 8 is 3. 100 would be 2 quad 8 is a rigid. Multiplication would be trivial, just add exponents. But addition would be nightmarish. Simple arithmetic would require factoring numbers. The Paraham people of the Amazon have no numbers at all beyond fews and many. They can't count precisely, can't do arithmetic, and seem perfectly happy. You're watching an anthropologist try to teach them numbers. They laugh and refuse. In their world, exact quantity doesn't matter. They've opted out of the entire mathematical revolution. Base 26 using letters would mean every word would also be a number. Cat would equal 2023. Dudog would be 2917. Poetry would have hidden mathematical meanings. Writers would be numerologists by default. Every tweet would be both message and calculation. Let's talk about what almost was. In the 1960s, Britain was on the verge of full decimalization. You're in Parliament watching the debate. Should they decimalize everything or just currency? They choose half measures, decimal pounds but imperial distances, metric science but imperial pubs. It's mathematical schizophrenia, and they're still living with it. If Britain had fully decimalized in the 1960s, the entire Anglophone world might have followed. America, seeing its parent country go metric, might have switched too. Instead, you have British engineers using metric professionally, but thinking in imperial personally. They're bilingual in measurement, which sounds impressive until you realize it doubles the chance for error. You're on the Mars Climate Orbiter team in 1999, watching in horror as your spacecraft crashes, because Lockheed Martin used imperial units while NASA used metric. The probe hits Mars at entirely the wrong angle because someone measured force in pounds instead of newtons. It's a $327 million reminder that mathematical diversity has costs. The persistence of non-decimal time is fascinating. Despite multiple attempts, nobody has successfully decimalized time. You're watching a Silicon Valley startup in 2015 try to create decimal time for the internet age. They fail spectacularly. Turns out astronomy doesn't care about mathematical elegance. The Earth's rotation and orbit aren't negotiable, but what if they were? Imagine humanity colonizing a planet with a 10-hour day and a 100-day year. Finally, decimal time would make sense. Colonists would use metric time, while Earth stuck with traditional hours. Scheduling interplanetary Zoom calls would be a nightmare. Is that 50 o'clock Mars time or 15 o'clock Earth time? You're in a linguistics lab studying how number systems affect thought. The Piraha can't learn to count beyond 3. Even when they try, their language shapes their mathematical capability. Meanwhile, Chinese children learn arithmetic faster because number words are more logical. 10-1 for 11 makes more sense than 11, a word that reveals nothing about its value. Japanese uses different counting systems for different objects. Long, thin objects use one set of numbers, flat objects another, small animals yet another. If this had spread globally, you'd need different numbers for counting apples versus oranges. Mathematics would be context dependent. Every equation would need to specify what kind of things you're counting. The Korean number system is perhaps the most logical. Pure decimal structure, no weird teen names. Everything follows patterns. Korean kids consistently outperform in early math, partly because their number system makes more sense. If Korean had become the global language, we might all be better at arithmetic. You're watching a Cherokee student write numbers in their syllabary. Cherokee has its own numeral system that almost nobody knows exists. Every culture that developed writing developed numbers, each slightly different. Humanity has invented counting dozens of times, but positional notation only a few times. It's harder to invent nothing than something. Binary cultures could have emerged if early humans had been slightly different. Imagine if we'd evolved with 2 fingers per hand. Base 4 would seem natural. All mathematics would be powers of 2. Computers would have been invented millennia earlier because the math would align with our intuition. There's a parallel universe where Roman numerals evolved to include positional notation. Romans discover 0 independently and create a hybrid system. Itsix means 9, but Itsix in means 91, 9 coquettes 10 plus 1. Roman mathematics flowers, the empire never falls, and you're reading this in evolved Latin on your wax tablet computer. Comment below which number system you think we should have adopted. Because the decimal system won not because it was perfect, but because it was good enough and spread at the right time. We're stuck with 10 not because it's optimal, but because we have 10 fingers and the Indians figured out 0 first. Let's dive into how the decimal system infiltrated every aspect of modern life in ways you've never noticed. You wake up, check your phone, and see it's 7:43 a.m. Those digits aren't just telling time, they're participating in a complex dance of decimal and non-decimal systems fighting for dominance. The 7 is decimal, but it's part of a 12-hour system. The 43 is purely decimal, but it's counting minutes in a 60-base system inherited from Babylon. Your phone number is pure decimal victory, 10 digits that uniquely identify you among billions. But it wasn't always this way. Early phone systems used letters and names. Pennsylvania 6 myth 5000 was actually 736 myth 5000. The decimalization of phone numbers was a deliberate choice to make international calling possible. You can thank the decimal system for your ability to drunk dial your ex from anywhere on Earth. You're typing a text message. Every letter you type is being converted to ASCII code, decimal numbers that represent characters. The letter A is 65. The spacebar is 32. Your emoji are Unicode decimal values. That laughing crying face is U+1 F602, which is 128,514 in decimal. You're literally texting in numbers pretending to be letters. Now check your bank balance. Those decimal points separating dollars from cents represent one of the greatest standardizations in human history. Before decimal currency, calculating interest was a nightmare. You're looking at 5.25% APR on your savings account. That percentage, another decimal innovation, makes compound interest calculable by normal humans. But here's where it gets weird. Stock markets trade in decimal prices now, but they used to use fractions. Until 2001, stocks traded in sixteenths. A stock would be 45 and 3/16. The switch to decimals saved investors billions in narrower spreads, but killed an entire generation of traders who thought in fractions. You're at the gas station. The price is $3.49 and 9/10 S. That 9/10 S is a bizarre non-decimal holdover, a fraction hiding at the end of a decimal price. It's mathematical manipulation, making you think gas is $3.49 when it's really $3.50. The decimal system is so powerful that retailers use fractions to subvert it. Your car's odometer clicks over to 50,000 miles, a nice round decimal number that means absolutely nothing except that humans like zeros. But your engine's computer is measuring everything in binary, converting to decimal just for your primitive analog brain. The RPM gauge showing 3000 is a decimal approximation of binary calculations happening thousands of times per second. You're buying groceries. The barcode scanner reads a 12-digit UPC code. Those stripes are decimal numbers encoded as varying line widths. The first digit identifies the product type. The next 5 identify the manufacturer. The following 5 are the product code. And the last is a check digit calculated using a decimal algorithm. Every beep at checkout is the decimal system saying hello. The nutrition label says 234 calories, 12 grams of protein, 45% of your daily vitamin C. All decimal, all arbitrary, all based on a 2000 calorie diet that applies to basically nobody. The decimal system has become so dominant that we use it even when it doesn't make sense. Why not measure nutrition in base 12 so portions divide evenly? Your GPS coordinates are decimal degrees, 37.7749 degrees N, 122.4194 degrees W. But degrees are base 60, so we've decimalized a Babylonian system. It's mathematical colonialism, forcing decimal notation onto sexagesimal measurement. Your location is a hybrid monster of competing number systems. Let's talk about how the decimal system shapes your digital life in ways that would terrify you if you understood them. Every photo you take is millions of pixels, each with RGB values from 0 to 255. Why 255? Because that's 2 circumflex 8 mind, the maximum value of an 8-bit binary number expressed in decimal. Your selfies are decimal representations of binary data pretending to be colors. You're streaming music on Spotify. The song is sampled at 44,100 times per second. Why that specific number? Because it's 2 circumflex, 2 colors, 3 circumflex, 2 colors, 5 circumflex, 2 colors, 7 circumflex, 2, chosen for its many factors, expressed in decimal. Every beat you hear is the decimal system vibrating your eardrums at precisely controlled intervals. Your credit score is a 3-digit decimal number that determines your financial fate. 750 is good, 650 is mediocre, 550 means you're sleeping in your car. This arbitrary decimal scale, invented in 1989, controls whether you can buy a house, get a job, or rent an apartment. Your worthiness as a human has been reduced to a decimal number. You're playing a video game. Your health is 100/100ths. Your experience points are 45,678. Your damage is 234 per second. Everything is decimal because that's what humans understand, even though the computer is doing all calculations in binary. The game is constantly translating between number systems just so you can understand what's happening. Social media metrics are pure decimal manipulation. 1K likes instead of 1,000. 1.2 M followers instead of 1,200,000. We abbreviate large decimal numbers because they become meaningless. The difference between 1.2 M and 1.3 M followers is 100,000 people, but your brain treats it as a rounding error. You're checking the weather. 72 degrees Fahrenheit, 40% chance of rain, UV index of 7. All decimal, all trying to quantify the unquantifiable. What does 40% chance of rain even mean? It will rain 40% of the time, over 40% of the area. The decimal system gives false precision to uncertain predictions. Your smartwatch says you've walked 10,000 steps. This oddly specific decimal goal comes from a 1960s Japanese marketing campaign for a pedometer called Manpo-K, which means 10,000 steps meter. It has no scientific basis, but the decimal system makes it feel official. 10,000 sounds more legitimate than 9,847. You're filing taxes. Every calculation is decimal, but the tax code is so complex that software is required to navigate it. Your income is decimal, deductions are decimal, but tax brackets create discontinuous jumps. Make $40,525 and you're in the 12% bracket. Make $40,526 and you're in the 22% bracket. One decimal dollar changes everything. The stock market uses decimal pricing but still honors some fraction traditions. Stocks move in penny increments, but options often price in nickel increments. 5 cents a holdover from fractional days. It's decimal supremacy with pockets of resistance. You're booking a flight. The price is $347.83, a precisely decimal number that's completely made up. Airlines use AI to adjust prices in decimal increments based on thousands of variables. That 83 cents isn't random. It's calculated to extract maximum value from your wallet. The decimal system has become a tool of algorithmic capitalism. Now for the dark side of decimal dominance. You're sitting in a hospital where every medical measurement is decimal, but your body doesn't care about base 10. Your heart rate of 72 beats per minute is meaningful only because we've decided it is. Your blood pressure of 120/80 could just as easily be expressed differently, but decimal has colonized medicine. The dosage of medication you receive is calculated in decimal milligrams per kilogram of body weight. But medication errors often happen because of decimal point mistakes. Move that decimal one place and a therapeutic dose becomes lethal. The decimal system saves lives and takes them with equal efficiency. You're reading about climate change, 1.5 degrees Celsius of warming, 420 parts per million of CO2, sea level rise of 3.3 millimeters per year. These decimal numbers represent existential threat, but their precision makes them feel manageable. If we said the Earth is getting hotter instead of 1.5 degrees, would we take it more seriously? COVID statistics bombarded us with decimal data. 2.3% mortality rate, 94.1% vaccine efficacy, 6 feet of social distancing. The pandemic was experienced through decimal numbers that gave false certainty to radical uncertainty. That 6 feet was actually 1.8 meters in most of the world, because even pandemics can't escape measurement system conflicts. You're looking at wealth inequality statistics. The top 1% owns 32% of wealth. The bottom 50% owns 2%. These decimal percentages hide the brutal reality that half of humanity owns basically nothing. The decimal system can make inequality look like a math problem instead of a moral crisis. Cryptocurrency prices move in decimal amounts so small they need scientific notation. Bitcoin can be divided into 100 million satoshis. That's 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 Facebook annually. That precise decimal number represents the commodification of your entire digital existence. Your likes, photos, messages, and relationships, all worth less than a large coffee in decimal dollars. AI training datasets contain billions of decimal parameters. GPT-3 has 175 billion parameters. These numbers are so large they've lost meaning. The difference between 175 billion and 200 billion parameters is 25 billion more than all the stars you can see with the naked eye. But it's just a rounding error in AI development. You're watching the national debt clock tick up. $31,432,891,234,567 and climbing. Every decimal digit represents incomprehensible obligation. The numbers are so large that adding $1 million, a life-changing amount for any individual, doesn't even move the last significant digit. The decimal system has enabled surveillance capitalism. Every click is logged with a decimal timestamp. Every location is recorded in decimal coordinates. Every purchase is tracked in decimal dollars. You exist as a series of decimal data points in thousands of databases. Your life reduced to numbers in base 10. Climate models run millions of calculations using decimal representations of physical processes. But chaos theory tells us that tiny decimal rounding errors compound into completely different outcomes. The butterfly effect isn't just about butterflies, it's about decimal points in equations determining whether coastal cities survive. Comment below if you think the decimal system has made life too quantified. Because we've built a civilization where everything must be measured, counted, and expressed in base 10. The Indians gave us a tool for understanding quantity, and we've used it to turn quality into quantity, reducing human experience to decimal data points. Let's journey into the future of numbers, starting with quantum computing, where the decimal system faces its greatest challenge yet. You're in IBM's quantum lab, watching a quantum computer that doesn't use binary or decimal. It uses qubits that exist in superposition, simultaneously 0 and 1 until observed. The decimal system that conquered the world is useless here. We need new notation for quantum states. Quantum computers don't output decimal numbers, they output probability distributions. Instead of calculating that 2 plus 2 equals 4, they tell you there's a 97.3% chance the answer is 4, a 2.1% chance it's 3, and a 0.6% chance the universe is broken. The certainty of decimal arithmetic is replaced by decimal probabilities of maybe getting the right answer. You're watching researchers struggle to explain quantum calculations to classical computers. Every quantum operation must be simulated using millions of decimal calculations on traditional computers. It's like trying to explain color to someone who sees in black and white. The decimal system becomes a bottleneck for quantum progress. But here's the twist. Quantum computers might make the decimal system obsolete for certain calculations. Shorter's algorithm can factor huge numbers exponentially faster than classical computers. The RSA encryption protecting your credit card depends on the difficulty of factoring large decimal numbers. Quantum computers laugh at this difficulty. In 2019, Google's quantum computer achieved quantum supremacy, solving in 200 seconds a problem that would take classical computers 10,000 years. But here's the thing, the output was still converted to decimal for humans to understand. We're building godlike machines that have to dumb down their outputs to base 10 for our primitive brains. You're in a meeting where physicists are designing a quantum internet. Information will teleport instantly between quantum nodes, but addresses still need to be in decimal for compatibility with existing systems. It's like building a teleporter but having to use zip codes to specify destinations. The future might require new number systems entirely. Quantum information uses complex numbers, numbers with real and imaginary parts. Your quantum bank account might be 100 plus $50. What does imaginary money even mean? The decimal system can't express the full quantum reality. Artificial general intelligence, when it arrives, might not think in decimal at all. You're watching an AI researcher explain that neural networks use floating point numbers, decimal approximations of real numbers. But future AI might develop its own numerical representations we can't even comprehend. Imagine AI creating a number system based on prime factorization or continuous functions rather than discrete digits. Communications from advanced AI might look like beautiful patterns rather than decimal numbers. We'd need translator AI just to understand what the smart AI is calculating. Post-decimal computing is already happening. Neuromorphic chips mimic brain neurons and don't use traditional binary or decimal. They spike and accumulate in ways that can't be expressed in base 10. You're watching Intel's Lewis chip learn patterns without ever calculating a decimal number. Space colonization will challenge the decimal system in ways we haven't imagined. You're on Mars, where a day is 24 hours and 37 minutes. Do you keep Earth time with its decimal divisions, or create Martian time? The colonists vote to create a new calendar with 668 Martian days per Martian year. Suddenly, decimal Earth dates don't align with decimal Mars dates. Interstellar commerce will require number systems that work across light years of distance and years of time delay. You place an order to Alpha Centauri. By the time it arrives, inflation has changed the decimal value of everything. We need numbers that account for relativistic effects and time dilation. You're designing the first generation ship to another star. The voyage will take 400 years. How do you maintain decimal financial systems across generations who will never see Earth? Interest rates become meaningless. Currency needs to be redesigned. The decimal system assumes stable reference points that don't exist in interstellar travel. Alien contact, if it happens, will reveal number systems we can't imagine. You're at SETI when the first message arrives. It uses base 11 because the aliens have 11 tentacles. Their mathematics is fundamentally different. Concepts that are simple in base 11 are complex in decimal. We have to learn alien arithmetic just to say hello. But aliens might not use positional notation at all. They might use continuous mathematics, expressing numbers as waves or patterns. Their numbers might be more like music than digits. The decimal system would be as foreign to them as their system to us. You're in a xenolinguistics lab trying to design universal mathematical communication. The team realizes that any intelligence must understand prime numbers regardless of notation. Primes become the Rosetta Stone for interspecies communication. But how do you express primes without a number system? It's chickens and eggs all the way down. Genetic engineering might change how future humans perceive numbers. You're watching a presentation on enhanced cognition. Future humans might intuitively understand base 16 or process logarithmic scales naturally. Children might be born understanding exponential growth the way we understand counting. Imagine genetically modified humans with 12 fingers. They naturally think in base 12, making them better at mental math involving thirds and quarters. A genetic divide emerges between decimal humans and decimal humans. Number system racism becomes a thing. Brain-computer interfaces will let us think in binary while expressing in decimal. You think of a number, and your neural implant converts it to any base you want. Mental math becomes obsolete when you can think calculations into existence. The decimal system becomes just one option in your mental drop-down menu. Virtual worlds might use entirely different mathematics. You're in a VR universe where space has 5 dimensions and time runs backward. The decimal system doesn't work here. Numbers behave according to the coded rules of the virtual reality, not physical reality. Digital physics requires digital mathematics. The technological singularity might make all number systems obsolete. You're watching Ray Kurzweil predict that, by 2045, artificial intelligence will surpass human intelligence exponentially. At that point, decimal notation becomes a quaint historical artifact, like Roman numerals are to us. Post-singularity intelligence might not use discrete numbers at all. Everything could be continuous functions, probability clouds, quantum superpositions. Asking for your bank balance returns not a decimal number but a wave function that collapses when you try to spend money. You're in a philosophy seminar discussing whether numbers exist independently of minds to perceive them. If humanity goes extinct, does the decimal system disappear, or do the relationships it describes persist in the universe, waiting for another intelligence to rediscover them? The simulation hypothesis suggests we're living in a computer simulation. If true, the decimal system is just part of the code, arbitrary rules set by programmers in a higher reality. They might use completely different mathematics. Our decimal system could be their inside joke. Climate change might force us to abandon decimal growth models. You can't have 3% annual growth forever on a finite planet. We need number systems that express sustainability, not just quantity. Circular mathematics for a circular economy. You're watching economists design post-scarcity economics. When 3D printers can make anything from atoms, when fusion provides unlimited energy, what do numbers mean? The decimal prices we use assume scarcity. Post-scarcity might need post-decimal mathematics. Blockchain technology is creating new forms of value that decimal money can't capture. NFTs selling for millions of decimal dollars represent ownership of digital nothing. Smart contracts execute automatically based on decimal conditions. The decimal system is being used to build its own replacement. You're at a conference on the future of mathematics. A speaker proposes that advanced civilizations don't use number systems at all. They manipulate reality directly through consciousness. Mathematics is just training wheels for baby civilizations. The decimal system is our bicycle. Eventually we'll learn to fly. The universe itself might be mathematical, made of numbers rather than particles. You're listening to Max Tegmark explain his mathematical universe hypothesis. If reality is mathematics, then the decimal system isn't describing reality. It's a tiny subset of what reality actually is. But for now, you still need decimal numbers to buy coffee tomorrow. The future might be post-decimal, but the present is thoroughly base 10. Your alarm will go off at decimal hours and decimal minutes. Your payment will be decimal dollars and decimal cents. The Hindu-Arabic system that took 1,000 years to spread globally isn't disappearing overnight. Comment below what you think comes after decimal. Will we transcend discrete numbers entirely? Will quantum computing force new notations? Or will the decimal system, like the cockroach, survive everything we throw at it? Because the peaceful revolution that started in ancient India isn't over, it's evolving. Let's confront the dark truth about our decimal dependency. You're an engineer working on a nuclear power plant. A single misplaced decimal point in your calculations could trigger a meltdown. In 1999, the Mars Climate Orbiter crashed because someone confused pound force seconds with Newton seconds. But imagine a decimal error in reactor control software. One misplaced zero could turn a city into Chernobyl. The decimal system has become so fundamental that we literally cannot function without it. You lose the ability to use decimal numbers right now. Try to buy anything. Try to tell time. Try to make a phone call. You can't. Modern civilization would collapse in hours without decimal notation. We've built a single point of failure into the foundation of everything. You're watching a documentary about the 2010 flash crash. In 36 minutes, $1 trillion vanished from the US stock market because of decimal numbers in algorithms interacting in unexpected ways. High-frequency trading bots, making decisions in decimal microseconds, created a feedback loop that nearly collapsed the global economy. The decimal system enabled both the speed and the catastrophe. But here's the scarier part. We're teaching machines to make decisions based on decimal calculations we don't understand. You're looking at a neural network with 175 billion parameters. Each parameter is a decimal number. Nobody, not even the engineers who built it, knows what all these numbers mean. We've created decimal deities whose logic we can't comprehend. Machine learning models are black boxes full of decimal weights and biases. An AI denies your loan application based on millions of decimal calculations. You can't argue with it. You can't understand its reasoning. The decimal system has become a tool of algorithmic oppression, making life-changing decisions with mathematical certainty, but zero transparency. You're in a hospital where an AI is diagnosing cancer from medical images. It's 94.7% confident you have a tumor. That decimal percentage determines whether you get surgery. But the AI learned from biased data. Its decimal confidence masks the fact that it's worse at diagnosing people with darker skin. The decimal system launders discrimination through mathematical objectivity. Social credit scores in China reduce human worth to decimal numbers. Your score is 642. You can't buy train tickets. You can't get a loan. Your children can't attend good schools. Your entire life is constrained by a 3-digit decimal number calculated by algorithms you'll never see. You're watching Facebook's algorithm decide what 2.8 billion people see every day. Engagement metrics, decimal numbers measuring clicks and time spent, determine what information shapes human consciousness. The decimal system has become a tool for programming humanity at scale. Cryptocurrencies promise freedom through mathematics, but they're creating new forms of decimal feudalism. You watch as a whale, someone with thousands of Bitcoin, manipulates the market with a single transaction. Decimal wealth translates directly to power. The rich get richer through exponential mathematics, not linear addition. The attention economy measures your worth in decimal metrics. Views, likes, subscribers, followers, all decimal numbers that determine income, influence, and self-worth. You refresh obsessively, watching decimal numbers increment, your dopamine hijacked by base 10 notation. The militarization of mathematics is perhaps the darkest chapter in our decimal story. You're in a Pentagon briefing room where generals discuss kill ratios, acceptable casualty percentages, and probability of mission success, all reduced to decimal numbers. Human lives become statistics. A 73% chance of success means 27% chance of catastrophic failure, but the decimal precision makes it feel scientific. Drone strikes are authorized based on decimal confidence scores. The algorithm is 89.3% certain. This is a terrorist. That 10.7% uncertainty represents innocent lives, but it's just a decimal rounding error in the war on terror. The decimal system enables killing with statistical comfort. You're watching a presentation on autonomous weapons systems. Robots that decide to kill based on decimal calculations. No human in the loop. just algorithms calculating decimal probabilities and making life or death decisions in microseconds. The decimal system becomes the language of automated murder. Nuclear war planning involves decimal calculations of megadeaths. You're reading a classified document that casually discusses 140 million casualties as an acceptable outcome. The decimal system makes the unthinkable thinkable by turning human extinction into a math problem. But the violence isn't always physical. High-frequency trading firms fight wars in microseconds, using decimal calculations to extract wealth from pension funds and 401ks. You watch as an algorithm makes 10,000 trades per second, each shaving decimal pennies that add up to billions stolen from retirement savings. The gig economy reduces workers to decimal ratings. Your Uber rating is 4.73, too low and you can't work, too high and riders get suspicious. Your livelihood depends on maintaining a precise decimal range, calculated from the subjective opinions of strangers. You're in Amazon's warehouse where workers are tracked to the decimal second. 12.3 seconds to pick an item, 8.7 seconds to scan, 5.2 seconds to place in bin. Fall behind these decimal metrics, and you're fired by an algorithm. The decimal system becomes a tool of hyperexploitation. Insurance companies use decimal calculations to deny healthcare. Your risk score is 73.2, just above the 73.0 cutoff for coverage. That 0.2 difference, a rounding error, determines whether you live or die. The decimal system puts a precise number on the value of your life. Credit scores create decimal castes. Below 600, you're untouchable. Above 800, you're Brahmin. The decimal system that ancient India created has become a tool for creating rigid social hierarchies that would horrify its inventors. You're watching a city implement predictive policing. Algorithms calculate decimal probabilities of crime for every city block. Police patrol based on these numbers, creating self-fulfilling prophecies. The decimal system becomes a tool for perpetuating systemic racism through mathematical legitimacy. But perhaps the most insidious aspect of decimal dominance is how it shapes our thinking. You're in a psychology lab, studying how humans perceive value. People will drive across town to save $10 on a $50 purchase, but won't bother for $10 off a $500 purchase. The same decimal amount has different psychological weight depending on context. The decimal system tricks our brains. Anchoring bias makes us vulnerable to decimal manipulation. A store marks up prices by 100%, then offers a 50% discount. You feel like you're getting a deal, but you're paying the original price. The decimal system enables mathematical gaslighting on a massive scale. You're watching a marketing meeting where executives discuss pricing psychology, $39.99 instead of $40.00. That one decimal cent difference increases sales by 15%. The decimal system hacks our cognition. We're psychologically vulnerable to specific decimal patterns. The gamification of everything turns life into decimal scores. Your fitness app congratulates you for 10,000 steps. Your meditation app tracks 1,000 consecutive days. Your language app celebrates 100-day streaks. The decimal system becomes a tool for behavioral control, making you addicted to arbitrary decimal milestones. You're studying income inequality statistics. The difference between $50,000 and $60,000 feels huge. The difference between $1 million and $1,010,000 feels trivial, but it's the same decimal difference. Our brains can't properly comprehend large decimal numbers, making us blind to extreme inequality. The decimal system creates false precision, Climate models predict 1.5 degrees Celsius warming by 2040. But that's a range of possibilities collapsed into a single decimal number. The precision implies certainty that doesn't exist. We make civilization-scale decisions based on decimal approximations of chaos. You're in a boardroom where executives discuss quarterly earnings. The stock price depends on beating decimal estimates by decimal pennies. Miss by $0.01 per share, and billions in market cap evaporate. The entire economy dances to the tune of decimal rounding errors. GDP growth of 2.3% is considered healthy. 1.9% is concerning. That 0.4% decimal difference determines monetary policy, government spending, and political outcomes. Millions of jobs depend on decimal points in economic statistics that are themselves estimates with huge error bars. The decimal system enables surveillance capitalism by making everything quantifiable. Your location, activity, interests, relationships all reduced to decimal numbers in databases. You exist as a mathematical model, a collection of decimal probabilities used to predict and manipulate your behavior. We've confused precision with accuracy, decimal places with truth. You can calculate pi into 1,000,000,000,000 decimal places, but it won't make your circle any rounder. The decimal system gives us the illusion of control over things we don't actually understand. Comment below if you think we've given too much power to the decimal system. Because we've built a civilization where everything must be measured, where what can't be counted doesn't count, where decimal numbers have more authority than human judgment. The peaceful revolution that brought us easy calculation has become a tool for control, manipulation, and dehumanization. So here we are, at the end of our journey through the peaceful evolution of the Hindu-Arabic number system, and I need to tell you something that might blow your mind. You're living in the most successful intellectual colonization in human history, and you probably thanked your colonizers for it. Every time you write a number, calculate a tip, or check your phone, you're participating in a cultural victory so complete that we've forgotten it was ever a contest. Think about what we've discovered. A notation system developed in India, refined by Arab scholars, resisted by European authorities, and eventually forced upon the world through commerce and convenience. No armies marched for zero. No one was conquered in the name of place value. Yet this system achieved what Alexander, Caesar, and Napoleon couldn't: true global dominance. You're sitting here in the 21st century, unable to imagine mathematics without these 10 symbols. But remember, for most of human history, people calculated without them. The Egyptians built pyramids without zero. The Romans built aqueducts without decimal points. The Greeks developed geometry without positional notation. They weren't stupid, they just had different tools. The decimal system won not because it was perfect, but because it was viral. It spread through trade routes like a beneficial disease, infecting anyone who tried it with the inability to go back to inferior systems. Once you've experienced the elegance of positional notation, Roman numerals feel like mathematical torture. But here's the beautiful irony. The very universality of the decimal system might be its downfall. You're watching as quantum computers develop, as AI evolves, as we prepare to meet alien intelligences. The decimal system that unified human mathematics might be the thing that limits us. We're approaching the edges of what base 10 thinking can accomplish. Future historians might mark the decimal system's dominance as humanity's mathematical adolescence. We needed training wheels to learn the bicycle of calculation, but training wheels that help you learn also prevent you from doing tricks. The decimal system got us this far, but it might not get us further. You realize that every technological marvel around you depends on those 10 symbols refined in ancient India. Your smartphone, the internet, space travel, modern medicine, none of it exists without efficient calculation. The decimal system isn't just part of history, it's the foundation that made modern history possible. But we've also seen the dark side. The same system that enables precise calculation enables precise control. The decimalization of human experience reduces life to numbers, people to statistics, existence to data points. We've gained mathematical power, but lost something ineffable in the process. The question isn't whether the decimal system was good or bad. It simply was, and is, and will be, until something better comes along. And something better will come along. It always does. The Roman numerals seemed eternal until they weren't. The abacus was revolutionary until it wasn't. The decimal system is dominant until it isn't. Let me paint you a picture of what actually happened here. Over the course of 2,000 years, humanity underwent a cognitive revolution disguised as a notation change. The adoption of the decimal system wasn't just about easier calculation, it was about democratizing mathematical thinking. Before Hindu-Arabic numerals, complex mathematics was the province of elites with years of training. After, any merchant could keep books, any craftsman could calculate proportions, any farmer could figure compound interest. This democratization changed everything. The Renaissance, the scientific revolution, the industrial revolution, all impossible without widespread mathematical literacy enabled by the decimal system. You couldn't have Newton's physics with Roman numerals. You couldn't have Darwin's statistics with counting boards. You couldn't have Einstein's relativity with additive notation. You're the beneficiary of 1,000 years of mathematical evolution. Every decimal point in your bank account, every digit in your phone number, every number in your address exists because Indian mathematicians had the audacity to say that nothing was something and position mattered more than symbol. But here's what should really bake your noodle. The decimal system succeeded because it aligned with human cognition, 10 fingers, natural counting, intuitive place value. But human cognition is just one form of intelligence. As we create artificial minds and potentially encounter alien ones, we're discovering that decimal might be a local maximum, not a global optimum. The peaceful revolution isn't over. It's evolving. Quantum computers think in superposition. Neural networks think in high-dimensional spaces. Future intelligences might think in ways we can't conceive. The decimal system will be translated, transcended, and eventually transformed into something unrecognizable. You want to know the real lesson of this story? It's not about numbers, it's about how ideas spread, how systems change, how revolutions happen without violence. The Hindu-Arabic numerals conquered the world through pure utility. They won because they worked. No ideology, no force, just functional superiority slowly recognized over centuries. This gives me hope for other peaceful revolutions. If something as fundamental as how we count can change globally through gradual recognition of superiority, what else might transform? Could we replace destructive systems with beneficial ones simply by demonstrating that they work better? Could the next revolution be as peaceful as the spread of zero? But it also serves as a warning. The decimal system shows how completely an idea can colonize thinking. We literally cannot imagine alternatives because decimal notation has shaped our cognitive architecture. What other assumptions have colonized our minds so thoroughly that we can't see past them? The Hindu-Arabic number system's victory was so complete that most people don't know it was foreign, don't realize it was revolutionary, can't imagine it being different. That's true power, not forcing compliance, but making your system seem like the natural order of things. So what do you do with this knowledge? First, appreciate the elegant simplicity of writing 2024 instead of MMX guy. Every time you calculate something quickly, thank ancient Indian mathematicians for the gift of positional notation. Every time you use zero, Remember that representing nothing as something was once revolutionary, but also stay alert to the decimal system's limitations. When you see precise decimal statistics about uncertain things, remember that precision isn't accuracy. When algorithms make decimal calculations about your life, remember that reducing humans to numbers is a choice, not a necessity. When decimal metrics determine your worth, remember that what counts isn't always what can be counted. The story of the Hindu-Arabic numerals teaches us that fundamental changes take time. It took Europe 500 years to fully adopt an obviously superior system. Change happens, but it happens slowly, and it happens through demonstration rather than argumentation. You don't convince people to abandon their systems. You show them something that works better and wait. We're living through other notation revolutions right now. Programming languages are creating new ways to express logic. Emojis are creating visual communication that transcends linguistic barriers. Memes are spreading ideas through images rather than words or numbers. Each is a peaceful revolution in how we encode and transmit information. The decimal system also shows us that the most powerful technologies become invisible. Nobody thinks about Hindu-Arabic numerals as technology. They just are. Like air or language, they're so fundamental that we forget they were invented. The ultimate success of any notation system is to become unnoticeable. As we stand on the brink of potentially meeting non-human intelligence, whether artificial or alien, the decimal system reminds us that communication requires shared notation. We'll need new Rosetta Stones, new universal languages, new ways to bridge different forms of mathematical thinking. The peaceful revolution that started with Hindu-Arabic numerals might be humanity's practice run for even greater challenges. Comment below what you think the next mathematical revolution will be. Will we abandon discrete numbers for continuous functions? Will we develop notation for quantum superposition? Will we discover that aliens use completely different mathematics? Because the story of the decimal system isn't ending, it's entering its next chapter. The peaceful evolution of the Hindu-Arabic number system is ultimately a story about you. Every number you write connects you to Indian mathematicians from 1,600 years ago. Every calculation you perform uses tools refined by Arab scholars a millennium past. Every decimal point places you in a tradition of human knowledge stretching back to before written history. You are the current carrier of an ancient flame, using notation developed over centuries to navigate a world those inventors couldn't imagine. Your smartphone calculations would seem like magic to Brahmagupta, but he would recognize every digit. The peaceful revolution succeeded so completely that you carry it with you everywhere, use it constantly, and never think about it. And that's the most beautiful part. The greatest innovations don't feel innovative, they feel inevitable. The Hindu-Arabic number system conquered the world so thoroughly that we can't imagine the world without it. It won by making every alternative seem impossible. So next time you write a number, remember you're participating in humanity's most successful peaceful revolution. Remember that notation is power, that systems can change without violence, and that sometimes the most profound transformations happen one calculation at a time. The decimal system's journey from ancient India to your pocket is proof that good ideas given enough time will triumph. Not through force, not through ideology, but through the simple undeniable fact that they make life better. And in a world that often seems dominated by conflict and coercion, that's a revolution worth celebrating. Thank you for joining me on this journey through the peaceful evolution that changed everything. Keep counting, keep calculating, and keep questioning the systems we take for granted. Because the next peaceful revolution might be hiding in plain sight, waiting for someone like you to notice that there's a better way. And remember, every time you use a number, you're part of a story that started with ancient mathematicians who dared to imagine that nothing could be something, that position could carry meaning, and that 10 symbols could describe infinity. That's not just mathematics. That's magic.